because only 19 of you have joined. So let us wait for a couple of minutes. Okay, so do you have any one of you have any question about the last class? If you have any question, you can ask. Or in fact, I want more interaction during the class because otherwise it become very boring. Okay, so sometimes I mean whoever I can understand that you are attending this class from your home, you may not have very good internet connection. But who have good internet connection, they can also switch on their videos because I mean that will give me some energy to do the class. Otherwise, it's become very boring.
Sir, I don't have any question, but I want to say something.
Yeah.
Sir, it will be very good if you can have a mic or something because your voice is not that much clear when you teach on the blackboard.
Yeah, I understand. I know that. I have also noticed that his voice is not clear. So actually, I have ordered a mic. Hopefully, next week I'll be able to teach with that mic. Okay. So I noticed that.
Okay,
Whenever
perfect. Perfect.
I saw the video, lecture video of this class, I noticed that the voice is not clear. So I ordered a mic. So hopefully, in the next class, I'll be more. I will not. Okay.
Okay, okay.
So sometimes someone is saying that sometimes video quality drops. Yes. So that is also a problem, but that is a problem of internet. Okay. So
No, sir, actually the quality doesn't drops. The focus changes. The focus changes from the blackboard to you. That's why the blackboard is little bit blur.
okay. So I do not know. I am using my laptop webcam. Okay. So that may be the problem. I can also try to. I mean, try to have some better webcam, but I do not know that will be able to handle this problem or not. I do not know that can focus. So that problem I don't know I will be able to solve it or not. But the voice quality actually I have already planned to solve this problem. Okay. So any other thing? Any other comment or question? Okay. So if not, let us start. So in the last class, what I have done, I have give you some basic idea about what is equilibrium, what is the system, why we are interested in thermodynamics, how we can parameterize, I mean how we can quantify the coordinate called temperature. So these are the things what I have discussed in the last class. So I will go to the next part of this course, but before that, I will give a brief recapitulation of whatever done in a different way. Whatever I have discussed in the last class and what are the importance of those things, I will give you a brief recapitulation about that and formally define what is thermodynamics. Okay, so So what is thermodynamics? Now we can formally define what is thermodynamics. Thermodynamics is a phenomenological description.
Sir? Hello,
Yes.
sir. Sir, can
Yes.
you write a little bit down? It is not visible.
Right, it will be down. Okay. So
Yes, okay, sir. It's okay now.
Okay. So let us mark the line. So can you see here? This is okay.
Yes, sir.
Okay. So let us mark the line. So I will write below this one. So it's a phenomenological description of macroscopic properties of a system in equilibrium. Okay, so this is a phenomenological description. I will discuss, I will talk what is the phenomenological, what is the, how we can define a phenomenological description of a macroscopic properties of a system in equilibrium. So I have underlined few words: phenomenological, macroscopic, system, and equilibrium. So these are the words you need to carefully understand. So these things, now what are the macroscopic property? What is a system? And what is equilibrium? So these are the things I have discussed in the last class. So I have discussed from the very scratch that what do you mean by macroscopic properties of a system? What is a system? First of all, it starts with a system. What are the macroscopic properties of systems and equilibrium? So these things I have discussed in the last class. So this is thermodynamics is all about. It's a phenomenological description of the macroscopic properties of a system in equilibrium. Okay, so system I have defined. It could be a isolated system surrounded by walls which do not allow the system to interact harmony with the surroundings. So, adiabatic wall. Or it could be a system which surrounded by walls which allow heat transfer, isothermal walls. Okay. So this could be the system, it could be an isolated system, it could be a non-isolated system which can interact with the surroundings. And the system could be, I mean, you can have different kind of system. You can have gases, you can have liquid, you can have mixture of gas and liquid, you can have a ideal, I mean, you can have a gas of particular kind. So these are the different kind of systems you can have. So you will find there are some names of this system. You can have a pure system. Pure system means that you can have gas, but it's a particular kind of gas. You can have a system of some solid, but it's a particular kind of solid. You can have a system of liquid, but it's a particular kind of liquid. You can have homogeneous mixture. Or you can have heterogeneous mixture. I mean, their definition is obvious. As the name suggests, a homogeneous mixture could be a mixture of different kind of gas, not a particular kind of gas. A particular kind of gas will give you a pure system. You can have some helium with some neon, this kind of mixture. Or mixture of different kinds of liquid or mixture of different kinds of solid, whatever. This is the homogeneous mixture. That is the kind of material is same, but they are, I mean, if you have gas, then you have a mixture of gas. If you have liquid, then you have a mixture of liquid. And if you have solid, then you have mixture of solid. So this is homogeneous mixture. And heterogeneous mixture is
Excuse
you
me, sir.
have some gas.
Sir,
Yes.
Sir, if I could have a moment of your time. Sir, sometimes the board is clear, but at many times when the video quality drops, the board is completely blurry and we are hardly able to read the words of it.
Okay,
So,
so as I discussed that as some
I
suggested that this is because of the fact that the focus of this camera is changing. I do not know. Do you have any idea how can I fix the focus of this camera on blackboard?
it would be
so you
better
can
if
try going to the settings of the meeting.
Hmm?
So, like in the lower end of the screen, you can see three dots. You can go to the settings there and try to change the send quality of the video.
Okay, so I can go to the settings of what? Settings of this Google Meet.
Google Meet, yes, sir.
Okay, so where it is? Can you just guide me? Settings. Okay, I
So
find
can
it.
you see
Okay.
like turn on, then video,
Video. Okay.
and then send resolution to like 720p.
Okay. In the resolution. Okay. Yeah. 720. Yeah. Okay.
I
Okay.
guess that might help.
Okay. Then resolution. Okay, done. Is it better? Is it better now?
Yes, sir.
It's better, right? Okay, good. Thank you. So as I was discussing pure heterogeneous, homogeneous, so these are some names, and from the names actually, I mean, this is quite obvious that heterogeneous mixture actually is a mixture of gas and liquid together. So you can have some gas on top of some water, right? So that is also a thermodynamic system, but you have two different kind of substance for the thermodynamic system. Those kind of mixture we call heterogeneous mixture, and these are some general system we will be talking about in this lecture. Okay, so this is the system. Next thing is the equilibrium. So that also I have discussed in the last class. So now let us assume this particular system which is isolated from the surroundings by adiabatic walls. Okay, now if I do one thing, if I remove the adiabatic wall from, I mean this is fine perfectly equilibrium because these thermodynamic properties are not changing. Now if I remove the adiabatic wall from the top and replace the adiabatic wall by a wall which can interact thermally with the surroundings. If I do that, now what will happen? Heat will, I mean, the system will thermally interact with the surroundings and it will go to a inequilibrium state. If we wait for sufficiently longer time, then the system will thermally equilibrate with the surroundings, and I mean, the system will have a uniform heat distribution, uniform pressure distribution, and uniform the fixed volume. So the system will again reach to a equilibrium state. So this is what we mean by equilibrium. So thermodynamics is a description of equilibrium states. It cannot describe inequilibrium states because for an equilibrium state you cannot have macroscopic description of the states, because macroscopic description is given by the properties, by the coordinates of the systems which you can measure. You can measure temperature, you can measure volume, you can measure pressure. But if you have an equilibrium system, that system do not have a uniform pressure. That system do not have a uniform temperature. Volume may be fixed because and volume may also may not be fixed. But yeah, so the point is that for an equilibrium system, you cannot define what are the macroscopic coordinate of the system. And if you cannot define the macroscopic coordinate of the system, it is not possible to have a thermodynamic behavior, thermodynamic description for the system. So system, equilibrium, macroscopic properties, these three things have been discussed in the last class, and these are the just the brief outline of whatever have been discussed in the last class. Okay, I will come to the phenomenology. What we mean by phenomenological description? I will come to that. But before that, it is important. I mean, you have started to. You need to study this thermodynamics. So you should be clear about the question that why you should study thermodynamics. First of all, it's a very old topic, right? It started at 16th century, just after the Newtonian mechanics. So Newtonian mechanics, when Newton postulated his laws of mechanics, that actually solves one particular class of problem. That is the mechanical interaction between different objects. This kind of problem has been solved by Newtonian by the postulates of Newton. But there are another kind of phenomena, which are the thermal phenomena. Actually, Newtonian mechanics cannot address those phenomena. So, in order to address those phenomena, this particular topic, thermodynamics, have been people have started to study how you can heat a bucket of water, how heat transfer from one object to another object. What are the thermal properties of different objects? So that topic is thermodynamics. So this is a very old subject. And moreover, the laws of this subject, whatever the laws of thermodynamics you will study in this course, you will see that from a more fundamental mathematical model, which is the statistical mechanics, more fundamental, precise description of the system, we will be able to derive those laws. In your next course, you will see that. So that will be the statistical mechanics course, where we will use some more precise properties of the system, which are the microscopic properties of the system. And using those microscopic properties, we will be actually deriving the laws of thermodynamics. Okay, so this you will do in some next classes. So the question is, if we are deriving the laws of this subject from a more fundamental and more precise description of the system, and if this subject is so old, so why we should study thermodynamics? So there are two answers for this. I mean, I will give you two arguments why you should study thermodynamics. So first argument is that, so this is a very powerful, this is a very beautiful, you can say a beautiful or a very powerful way to start with the system. To start with the system which is a black box to us. We do not know anything about the system. We will do some experiment. We will observe some properties of the system, and based on those observations, what we can do, we can gradually postulate a mathematical framework that can predict the future behavior, or that can predict the properties of the system, thermodynamic properties of the system. So that will be the objective of the thermodynamics. This is a great example of the fact that if you do not know anything about the system, how you can start looking at the system, do some different observation, different experiment, measure some property of the system, and from those measurements you predict. You do a mathematical modeling, postulate some laws, you do mathematical modeling, and predict the future behavior, other behaviors of the system. So how we can do that? Thermodynamics actually will teach us. So how this can be done. How we can do that? I mean, what are the mathematical paths to do that? So that we will learn in this course. And next thing is that, as I told you that in other courses like statistical mechanics, you will determine these laws of thermodynamics. We actually prove this, derive these laws of thermodynamics from more fundamental and precise description of the system. But the question is that if you do not have these laws, then you do not have a guiding principle, right? So in statistical mechanics or in that mathematical model, what you want to prove, you do not know. Since you have these thermodynamic laws before, so you know that this is my objective. This is what I want to establish. This is what I should look for. So thermodynamics will give a guiding principle to the statistical mechanics, which is more fundamental. So these are the two arguments I can give you right now to study this subject very carefully. Okay, so now, as you know, the properties of a system, the thermodynamic